Hello, Assalamu alaikum. My name is Fazal Wahab. You are watching my YouTube channel. We are continuing the chapter scalars and vectors, and the new topic which we will discuss today is the addition of vectors, how the vectors can be added. So this is our topic for today. So let's say we have two vectors, vector A, let's say this is vector A, this is a vector A, and we have another vector which is vector B, this is vector B. How to add these two vectors? We will use a method which is called head to tip to tail or head to tail rule. Tip to tail or head to tail rule, okay? And head to tail rule, what we will put this vector, for example, this is a vector. We will put this vector in the same direction as this one. These are the representative of these vectors, vector A, vector B. Now vector A, we will draw vector A in the same direction with the same magnitude. We will not change the direction, we will not change the magnitude. And then we will put the second vector to the head of the first one with the same magnitude and with the same direction. Direction shouldn't be changed, magnitude shouldn't be changed, but we will just put the second vector to the head of the first one, okay? This one is vector B. Now, head to tail rule, that's why it is called head to tail rule, because the head of the first one will be coincide with the tail of the second one. Similarly, if you have another vector which is vector C, let's say, this is vector C, this is third vector which is vector C. So what we will do, the head of the first vector will be coincide with the tail of the second one, and then at the head of the second one will be coincide with the tail of the third one, which is vector C, okay? And then finally we will coincide the tail of the first one to the head of the last one, this one, and this will call the resultant vector. The direction of the resultant vector will always be from the tail of the first one to the head of the last one, and this is called head to tail rule or tip to tail rule, which is a very simple method. Again, we have three vectors, vector A, vector B, vector C. These are the representative lines of these vector A, B and C, and we have to add these three vectors. So what we will need to do by using head to tail rule, what we will do in head to tail rule, we will draw this vector A with the same magnitude in the same direction. This is vector A. Now we will put vector B to the head of the vector A. We will coincide, okay. And then we will put vector C to the head of the vector B. So what is head to tail rule? The head of the first vector will be coincide with the tail of the second one. The head of the second one will be coincide with the tail of the third one. And finally, we will coincide the tail of the first one to the head of the last one. And this will form the resultant vector. The direction of the resultant vector will always be from the tail of the first one to the head of the last one, okay? Now let's say we have two vectors. This is called the addition of vectors, okay? Let's say we have these two vectors, vector A and vector B. When we will add both of them, let's say this is vector A, and now we will add vector B to the vector A. We will put vector B to the head of the vector A with same direction, same magnitude. Now one way is this one, to now add both of them. This is the resultant vector of, this is called A plus B. A plus B, which is called the resultant vector. The resultant vector, which is this one, is A plus B. Okay, another thing we can do is to put the vector B first and then add vector A to the vector B. We can do this one in the same way. For example, this is vector B, this is vector B, okay? And now we put vector A to the vector B. This is vector A. This is vector A. So in both the cases, we will get the same resultant vector. If we put vector A first and add vector B to vector A, and we will get the resultant vector, which is R is equal to A plus B. And the second case, we will put vector B first, and then we will put vector A to the head of the vector B, and we will add vector A to the vector B. We will get the same resultant vector A, the first one. This resultant vector will be for both the diagrams, for this one and also for this one. So A plus B, we can say this is A plus B is equal to R, this one. Similarly, B plus A is also the same vector, which is the resultant vector. A plus B is R, and B plus A is also called R, is also the resultant vector R. So therefore, A plus B is equal to B plus A, and this is called the commutative law of vector addition. A plus B is equal to B plus A. This is called the commutative law of vector addition. When you add A plus B, and you get the same result when you add B plus A. In both the cases, you are getting the same results. There is no difference between A plus B and B plus A, and this is called the commutative law of vector addition. So vector addition, commutative law can be applied on the vector addition. Okay, second thing is subtraction of vector. How we can subtract two vectors? For example, again we have the same vectors. We have a vector, let's say P, this is vector P, and another vector is vector Q. Let's say this is vector Q. We have two vectors. Now we wanted to find out P minus Q. What? P minus Q. Okay, so what we will need to do to P minus Q, P vector will be, we will draw the P vector. This one is P vector. Okay, let me do it here. This is vector P, same magnitude, same direction, vector P. Now how can we subtract vector Q from vector P? We will take the negative vector of vector Q. The negative vector, what will be the negative vector for vector Q? With the same magnitude but completely opposite in direction will be the negative vector of vector Q. So what will be the negative vector for vector Q? This will be the negative vector for vector Q. This is minus Q. This is minus Q. Because with having the same magnitude but completely opposite in direction, 180 degree, there should be an angle of 180 degree between the vector and the negative vector of that vector. We have this vector, vector Q. So the negative vector of vector Q will be this one, which will have the same magnitude. If it is 10 centimeter, that should also be 10 centimeter, but the direction will be completely opposite. 180 degree of the direction will be 180 degree. Okay, this is 180 degree, for example this one, and this is 180 degree. Both have exactly the same, the opposite direction. So now what we will need to do, we will create another vector which is the negative vector of vector Q, and then we will add that negative vector to vector P. Now this is, we will add this one. This is negative Q. So this now coincide the tail of the first one to the head of the last one. Now it is P minus Q. P minus Q. Okay, very simple way. If you want to subtract a vector from another vector, the vector which has to be subtracted, take the negative vector of that and add to the first one. You want to subtract Q from P, take the negative vector of Q is this one, and then add the negative vector of P to the of Q to the P, and you will get the subtraction of the two vectors, P minus Q. You will get this one. Okay, this is very simple way. Third one is the multiplication of vector. How can we multiply two vectors by a number? For example, you have a vector, this is a vector A, which is equal to 2 centimeter. Let's say the length is 2 centimeter. It's 2 centimeter is the length. I mean magnitude of vector A is 2 centimeter, suppose. And we are multiplying this vector. Let's say we want to multiply this, we wanted to find out 3A. Okay, multiplying this vector with the 3, with a number 3. So what the direction will remain the same. We will not change the direction, but we will take a vector whose magnitude is 3 times of the original vector. For example, it is 2 centimeter, 3 2s are 6 centimeter. 3A will be equal to 6 centimeter. This will be a 3A. Okay, and this will have the magnitude of this vector will be equal to 6 centimeter. 6 centimeter. So the negative vector of when we have to multiply a vector with a number, direction will not be changed, direction will remain the same, but the magnitude, if you are taking twice of the vector, that will become double. If you are multiplying the vector with 3, so you will get the thrice of that vector. For example, you are having a vector whose magnitude is 2 centimeter. You are multiplying with the 3, you will get 6 centimeter. Magnitude of that vector will be 6 centimeter, and that will be called the vector which is equal to 3A. The direction will not change, that will remain the same.